Section 13.6 continued. Take note, properties of tangent functions on page 870. Suppose y equals a tangent of b theta. Pi over b is the period of the function. Notice it's different. It's not 2 pi over b here. For tangent, it's just pi over b. One cycle occurs in the interval from negative pi over 2b to pi over 2b. That looks a little weird, guys. All they're saying is you take your period, and the center of it is at that. Half goes before, half goes after. There are vertical asymptotes at each end of the cycle. Because remember, tangent is y over x. So when x is 0, we can't have that. When x is 0, we can't divide, and it becomes undefined, which gives us an asymptote. So we're going to graph here 2 cycles of the graph of y equals tangent of pi theta. So a is 1, b is pi. So to find our period then, since it's a tangent function, it's pi over b. So we get pi over pi, and our period is 1. Okay, that's how long, or how far, one cycle goes. We're going to graph 2 cycles. So I'm still going to mark off here. The only difference is here I'm going to make this 1, this a half, 0, negative half, and 1 1/2. Okay, so I still have my 4 parts, 1, 2, 3, 4, 5. Well, with my line, but 1, 2, 3, 4. Just like we did before. The only difference with tangent is it starts before 0. So we said our period is 1. What that means, guys, is that this right here is 1. This right here is another 1. Okay, and we don't start it at 1 or end it at 1. The whole numbers that are going to be our middle. Like 1 here is going to be the middle. Half's going to be before, half's going to be after. Okay? Okay, with tangent, in the middle, we have a point. And halfway, remember our endpoints are asymptotes. Middle are zeros, halfway in between. So here it's going to be like 1 1/2 over. And 1 is a point, halfway, and 1 is a point. And that's because that's like our 45-degree mark. And square root of 2 over 2 and square root of 2 over 2 gives us 1 when we take x and y. It's an increasing function, so we go down, up. I forgot to draw my point in there. 1 1/2, 1. 1 1/2, 1. And so 2 cycles. Okay, so our big thing for tangent is to center at period. There's also a point there. 0. At your period. And then halfway in between asymptotes, we have a point at 1. Halfway between asymptote and y equals 0, point at -1 or 1. -1 on the negative side, +1 on the positive side. Okay, so this right here is like the version of like 2 pi, kind of, when you do 2 of them. So tangent's a little bit weird in that the period is only 1, but a lot of things are similar in that it just keeps repeating. So a equals 1, b equals 3. So we use the b to take pi over b to get our period, which here is going to be pi over 3. And remember that tangent is 1 pi for it to be the period. So I'm going to go at pi over 3 at like my 1 pi mark on my normal graph. Half of that is pi over 6. So 1 pi over 6, 2 pi over 6, 3 pi over 6, which is pi over 2, and negative pi over 6. Okay, we have to label all those. Now, our a value is 1, so our amplitude is going to be just 1, so I'm just going to put a 1 and a negative 1 here. And that's helpful because our points in between our asymptotes, and remember our asymptotes go on the edges here. Okay, our points between 0 and our asymptote halfway in between at negative 1 and 1. Halfway in between at negative 1 and 1. Then we connect the dots. I missed that one, but pretend I went through there. So kind of like that. Okay, a equals 1, b equals pi over 2. So we have pi divided by pi over 2. So pi times 2 over pi gives me a period of 2. So two, 3, 1, negative 1. Asymptotes on my endpoint and halfway in between. 0, 0. Halfway in between my 0 and my asymptotes, I have points at my amplitude, which here is just 1. Again, halfway between my asymptotes and 0, I have a point at either 1 or negative 1. Skip example 3 because we're not going to have one like that on our quiz or on our test. Big ideas there again, and here's the assignment.